Hi, I'm Akil, and I'm here presenting my Lab 3 for Physics 2211 about the black hole. Introduction, goals, and findings. The goal for part 1 of this lab is to find the mass of the black hole, and how I'm gonna do that is using a computational model. I'm gonna simulate gravity between a star and the black hole. And in part 2, the goal is to find the initial velocity of the spaceship so that it flies near the black hole but doesn't crash into it. And we're going to use a similar computational model for that. Preview of the results is that the mass of the black hole is 1.79 E34 kilograms. And the initial velocity of the spaceship is negative 4.1 E7, 2.2 E6, 0 meters per second. And formulas and key ideas. Using the star, I'm going to collect measurements on the parallel and perpendicular and the net force to measure the mass of the black hole. And how I'm going to do that is I'm going to manipulate the second law. So the net force is equal to the parallel force plus the perpendicular force, and the system is just a star and the black hole. Yeah, and these are the formulas I'm going to use. This is the code I use for part 1. The first set is like the constants, the gravitational constant, the mass of the star, and yep, this is the rest of my code. Code results. From the code, we got that net force is 9.78 E28 newtons, and the parallel component is 1.23 E28 newtons, and the perpendicular component is 9.7 E28 newtons. And from that, we got the mass of the black hole as 1.79 E34 kilograms. And the parallel line points in direction of the momentum, and the perpendicular line points towards the center. The formula and key ideas for part 2. We're going to determine what the initial velocity the ship must have when it leaves the surface of the planet, and we're going to use the same formulas to figure this out. This is my second. This is my code for part 2, and these are the constants from part 1 and the spaceship's initial velocity components. The results of the code is right here, and the magenta is the planet and the cyan is the spaceship. Possible sources of error. Because the model is computed through GlowScript, there aren't many possible sources of error because in the calculations and information, as it is what is expected because it's a code computational model. What does it mean? The distinction is that in part 1 of this lab, we were solving for dt, as we set it equal to the net force. Essentially, we're calculating the value of the net force to find the mass of the black hole. What if? Using the code and by doing trial and error, I found the orbit. I set the time equal to 120 minutes, and